Determine when the augmented matrix represents a consistent system. So we already have this beautiful augmented matrix here, and what we want to do is row reduce it to that upper triangular form. And we're row reducing it to its upper triangular form to look for any inconsistencies that we'll need to exclude to make sure that the system is consistent. So to get us started, we look at the entry in the x sub 1 position in the first row, and we want to use this to eliminate all these entries below it. So let's do one at a time just because it's our first time doing a big system like this. So how are we going to eliminate the entry in row sub 2, or the second row? Well, we're lucky in this case. We simply need to add the first row to the second row to produce that new and equivalent second row. So this leaves us with, our first row is still the same. That's 1, -1, 2, 1, m. And now we are reducing that second row. So we have 1 minus 1 gives us 0. We have -1 plus 3 is 2. We have 2 plus 1 is 3. We have 1 plus 1 is 2. And we have m plus a is m plus a. So there is our first manipulation. And the remaining rows are still the same. We have 3, -5, 5, 1, t. And then 2, -2, 4, 2, h. Alrighty, so our first simplification is done. And now we're moving on to the second. So we're still using that first pivot position, but we're thinking to ourselves, how can we manipulate the first row to eliminate the 3 in the third row? So what we're going to need to do is -3 times the first row plus the third row to attain the new third row. And here we go. So the first two rows remain as they are. 1, -1, 2, 1, m. The second row is still 0, 2, 3, 2, m plus a. And now we have -3 plus 3 is 0. We have +3 minus 5 is -2. We have -6 plus 5 is -1. And we have -3 plus 1 is -2. And last but not least, we have -3m plus t. So that's going to be t minus 3m. And our fourth row remains the same for now. All right. So, next. Now we are thinking, again, we're still in that first column, thinking about our first pivot, and how can we use that to eliminate the first position in the fourth row. So we're going to need to do -2 times the first row plus the fourth row to attain the new fourth row. And so this is equivalent to the following matrix. And so here the first three rows remain the same. We have 1, -1, 2, 1, m. We have 0, 2, 3, 2, m plus a. 0, 2, or excuse me, 0, -2, -1, -2, t minus 3m. And then here is our manipulation. We have -2 plus 2, which gives us 0. We have +2 minus 2, which gives us 0. We have -4 plus 4, which gives us 0. And last but not least, we have second to last, -2 plus 2 is 0. Now, last but not least, we have -2m plus h. And I'll just write this as h minus 2m. So, do you notice what's going on in that fourth row? This should be making you a little bit nervous. We should exercise caution here. in this case, the system is only going to be consistent if that right-hand side, h minus 2m, is equal to 0. So the system will have at least one solution if and only if h minus 2m is equal to 0. Otherwise, we'll have a contradiction. So let's be mindful of this as we proceed, and we'll see if there's any other contradictions that occur. So we have finished simplifying that first column, and we're moving to our second pivot position. So we want to use that second pivot to eliminate the entry below it. So we simply need to add the second row to the third row to get the new and reduced third row. So this will be equivalent to our first two rows remain as they are. 1, negative 1, 2, 1m, 0, 2, 3, 2, m plus a. And then here is our manipulation. We have 0 plus 0 is 0. We have 2 minus 2 is 0. We have 3 minus 1 is 2. 2 minus 2 is 0. And last but not least, we have m plus a plus t minus 3m, which leaves us with t plus a minus 2m. And the fourth row remains as it is, 0, 0, 0, 0, h minus 2m. And what lucky ducks we are. With that one last step, we have attained echelon form. Woohoo. Being mindful of the potential contradiction of the denominator, as previously stated. So we're ready to make our final conclusion, and we can say that therefore this linear system is consistent, or will have at least one solution, if and only if h minus 2m is equal to 0. And this is our beautiful final answer.